Good morning, students. I, Professor Satish Chandgwant, is going to take the subject called Mechatronics in this semester for you. First of all, congratulations to all of you for entering into the final year. So, let us begin with the first module, that is the Introduction to Mechatronics. We'll start with the definition. Mechatronics is synergistic integration of mechanical engineering, electronics, and intelligent computer control in design and manufacture of products and processes. So, in this definition, we can see that it is integration of mechanical and electronic and computer for the control in design and manufacturing of a product. So, usually in mechanical engineering, we are going to manufacture the products only by mechanical means. Similarly, electronics only by electronic means. But somewhere in the operation process, we need the integration of these both like mechanical engineering, sometimes computer also, and nowadays we require all the three so that the products manufactured are operated in an efficient way. So, coming to the definition, it is the integration of mechanical, electronic, and computer. So, this is the pure definition of mechatronics. So, working definition means practically, uh, according to the theoretical definition, what it is practically happens in mechatronics. So, according to the working definition, it is a synergistic integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithms, and computer hardware and software to manage complexity, uncertainty, and communication in engineered system. So, in practical definition, we can see that mechanical engineering, where what the products are basically mechanical in thing, then like actuators, see sensors, again it is a concept from the electronics. Signal conditioning, it is a concept of electronics. Power electronics, so again it is concept of electronics. Decision and control algorithms, when we come to the algorithms, we can say we have entered into the computer era. So, working definition includes what actually mechanical things are involved, electronics things are involved, and computer things are involved, like computer hardware and software. So, why we are integrating all these three things? Because to manage the complexity or uncertainty and to communicate between these systems, we are integrating all these three disciplines, that is mechanical, electronics, and computer. So ultimately, by the definition, we will come to know that mechatronics is integration of mechanical, electronics, and computer. Let us continue with the mechatronic systems. How the word mechatronics originally evolved. The word mechatronics was originated from Japan, that's Yasakawa Electric Company, in the late 1960s. Then it spread through Europe and is now commonly used around the globe. The word mechatronics is composed of mecha from mechanism and tronics from electronics. So we there are two words, or we can divide the mechatronics into two words. Mechatronics. Mecha means the mechanism. Tronics. So from mechanical it is taking mecha, and from electronics we have taken tronics. So it is composed of mecha, mechanism, tronics from electronics. Mechatronics solves technological problems using interdisciplinary knowledge consisting of mechanical engineering, electronics, and computer technology. We discussed it earlier. And one more important thing in this mechatronics is basically it is a multidisciplinary subject. So as we saw in the definition, it's the integration of mechanical, electronics and computer. So when we are going to study it, it's a multidisciplinary scenario. See, it takes the things from information systems, mechanical systems, electrical systems, computer systems. So all these will lead to mechatronics. See here in the circular diagram also we can see what are all the things involved in the mechatronics: control systems, digital control systems, computers, mechanical CAD, mechanical systems, electromechanics, electronic systems. So in the interior, at the outside, uh, automotive, aerospace, medical, xerography, defense systems, consumer products, manufacturing, materials processing. Xerography, it's a dry copying process. So it's like a photocopying where the image of the document is copied. So, a very important thing from mechatronics, we should know that it is a multidisciplinary scenario. Then, evolution of mechatronics. So, how it got so much scope in these days, how it evolved. Let us see. Technological advances in the design, manufacturing, and operation of engineered products or devices or processes can be traced through industrial revolution, semiconductor revolution, information revolution. So after industrialization, we have seen these three revolutions: industrial revolutions, where it began with the mechanical industry; semiconductor industry, where we it began with the electronics; and nowadays it is a information revolution. It's the era of internet. So evolution of mechatronics is can be traced through all these three revolutions: industrial, semiconductor, and information. What's industrial revolution? What happened in the industrial revolution? It allowed a design of products and processes for energy conversion and transmission, thus allowing the use of energy to do useful work. So, what happened in industrial revolution is we converted the energy to do useful work. Engineering designs of this era were largely mechanical. So, in industrial revolutions, most all the designs of the products were from mechanical based. For example, operations of motion transmissions, sensing, actuation, and computation were performed using mechanical components such as cams, gears, levers, and linkages. So all these were purely mechanical systems, but they were suffering, or there is a scarcity or a lack of power amplification inability. So whatever power they have produced, it could not have amplified, and energy losses due to tolerances, inertia, and friction. So ultimately, in industrial revolution, we were producing power or energy and we were converting it into work, but somewhere we were lacking to amplify or to magnify it, and we have losses of energy in the form of tolerance, inertia, and friction, which are not necessary or unwanted for the smooth operation process. So you can see some of the uh, mechanical designs here: float valve, Watts governor, cam operated switch, bimetallic strip, thermostat. So all these are evolved purely through industrial revolution. Bimetallic strip, it's whenever the change in temperature takes place, mechanical displacement will happen. Similarly, thermistor, actually it's a thermal resistor, it's called thermistor. It's an electrical resistor where resistance is greatly reduced by heating, and it is used for measuring and controlling the devices. So all these devices were made up of because of industrial revolution. But there were some loopholes in this energy. We were producing energy, and that was converted into work by these means, but we were losing the energy, and we were lacking in magnifying the energy or power obtained from this. Second, that is semiconductor revolution, which led to the creation of integrated circuit. So IC chips, you might have seen the hardware parts of the computer. It is made up of fully IC circuits, IC integrated circuit technology. So what is the specialty of the semiconductor revolution? It was very effective, miniaturized. Miniaturizer means small in size. Power electronics could amplify and deliver needed amount of power to actuators. Then signal conditioning electronics could filter and encode sensory data in analog or digital format. Hardwired onboard discrete analog or digital ICs provided rudimentary computational and decision making circuits for control of mechanical devices. So in semiconductor revolution, what happened was we started using IC, that is integrated circuit technology, and it was small in size, and signal conditioning electronics were filtering and encoding of sensory data in the analog or digital format, and all the things were in the wired form. So this happened in the semiconductor revolution. We can see the examples or devices which are miniaturized, that is small in size, in semiconductor revolution. An integrated circuit, first one. Second one, an A to D, that is an analog to digital converter. Third one is an op amp, that is operational amplifier. So these are the small devices we started using in or soon in the after the semiconductor revolution. Next, this is the era of information revolution. It is the development of VLSI technology, very large scale integrated circuits, that is called VLSI technology, led to the introduction of microprocessor, microcomputer and microcontroller. See, we are using the words micro in all the things. We are using the microprocessors, and that became very small in size. Computer, very small in size. Controller, very small in size. Micro. Now computing hardware is everywhere, cheap and small. As computing hardware can be effortlessly interfaced with the real world electromechanical systems, it is now routinely embedded in engineered products or processes for decision making. So earlier, for decision making, human interface was a lot. Now, because of the information revolution, decisions can be taken in the system itself. Microcontrollers are replacing precision mechanical components. For example, precision machined camshaft that in many applications functions as a timing device. Programmability of microcontrollers is providing a versatile and flexible alternative to the hardwired analog or digital computational hardware. So, programming or programmability in the microcontroller is very flexible, and we can use it as a alternative for wiring system. So all the wiring system is gone now. We are using only VLSI, that is a very large scale integrated chips in a small device. So earlier, to make a small device in semiconductor, or before that, we used to a lot of wires. So now in information revolution, we are avoiding all that wiring system, and we are trying to use as much as possible only the integrated circuits. Integrated computer electrical mechanical devices are now capable of converting, transmitting and processing both physical energy and virtual energy. So, what is the result ultimately because of this information revolution? So, it is highly efficient products and processes are now being developed. Judicious selection and integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithms, and computer hardware and software. So all these products we are using because of information revolution, and that too are very high efficient products, and there is a judicious selection of sensors, actuators and signal conditioning, power electronics, decision and control algorithms. Some typical examples are the pictures of microcontrollers. So ultimately, we can come to know that mechatronics has evolved through the four stages, that's primary, secondary, tertiary, and quaternary. Primary level mechatronics, where it integrated electrical signaling with mechanical action at the basic control level, for example, fluid valves and relay switches. Secondary level mechatronics, where it integrated microelectronics into electrically controlled devices, for example, cassette, tape, player. Tertiary level mechatronics, it incorporated advanced control strategy using microelectronics, microprocessors, and other application specific integrated circuits for example, microprocessor based electrical motor used for actuation purpose in robots. And now we are in the quaternary level of mechatronics, so where it attempts to improve the smartness a step ahead by introducing intelligence, that is artificial network, neutral network and fuzzy logic, and fault detection and isolation, which is called FDI capability into the system. So in the quaternary level of mechatronics, now we are introducing a very we are providing artificial intelligence also to the system, where it can make smart decisions with the help of internal fuzzy logic and neutral network, and even it can detect the faults itself and isolate the faults. So this is the specialty of the quaternary level mechatronics. So this is the small introduction for the today's session. We will continue for the further things in the next session. Any queries, let me know later in the afternoon. Thank you.